Greetings to you. Welcome to Physics with Ben. Don't forget to subscribe and share this video to those that need it. In today's video, we want to quickly look at how we can find the refractive index of a triangular glass prism. Using the equation, the refractive index from air to glass of this guy is equals to the sine half into A plus D subscript M, all divided by sine half A, where A simply means the angle of the interior angle of this triangular glass prism. In this case, this guy is 60, 60, 60 degrees, an equilateral triangle. So dm is the angle of minimum deviation. We'll get back to this equation later in this video. So let's go straight to the point. The apparatus we need here, we just need a tracing board, which is already what you are seeing here. We need this guy. We need 4 optical pins. We need a tracing paper. And we're going to fasten this to the tracing paper, to the tracing board, so that while drawing our diagram will be firm. The paper will be firm and not moving anyhow. We are good with that. The next thing we need 4 optical pins. 1, 2, 3, 4. Let's put them here. We need 4 optical pins. We need a protractor to be able to measure the diagram, the angle of incidence and the angle of refraction, and all the angles involved in this geometry. We need a very sharp pencil. We need a calculator. Then we also need a ruler. Don't forget, I have made a video on how to find the refractive index of a rectangular glass block. Click in the description box below and you see the video on this and you will watch it, and also all the theories involved in these guys. So let's go straight to the point. The first things first we need to do is to place the triangular glass prism here and then trace the outline. That's step 1. Place it, and you have to use one of your finger to hold it firm. The next thing is to draw the outline. We are done drawing the outline. Take it out. Then let's label this A, B, and C. Good. The next thing we have to do is to draw a normal perpendicular to surface AB or BA. Don't forget, as we did in the other video, you have to use your protractor to, this horizontal line here must align with this line AB. So we place it this way. Good. And then we put a dot on angle 90. We put a dot down here. We take it away. Then we join the 2 dots. That becomes our normal. If you are a technical student, you can extend this normal straight up. Oh, okay, no. Let's just leave it here. Just here. Yeah. Good. Let me clean this one. Good. Good. And so we can make this number NO. Good. NO. The next thing to do is to place the protractor on this number. This line must align with the number, and this horizontal line must align with this. So we are doing that to. Now let's choose any arbitrary incident angle. Let's choose this time our eye to be 40 degrees. In the other video, we choose our eye to be 30 degrees. Let's choose eye. Don't forget, as I said in the other video, that the refractive index of a glass media ranges from, that is from air to glass, ranges from 1.5 to 1.7. Sorry, 1.7. So if you are running any experiment and you get values that are outside this range, then what you have done is wrong. Good. So we agree that our angle will be 40 degrees. Mind you, the angle is taking reference from the normal and not on this surface. So we are counting anti-clockwise. So let's count. So this is 10, 20, 30, and 40. This time 40 is at the 50th degree mark. We take that away. And then the next thing is to draw a straight line that will pass through this place. That is supposed to be our incident angle, our incident ray. Good. Now, had it been this guy was not here, don't forget this is your air media, and this is your glass media, and then this is your air media. So this guy is traveling. I'm reaching this boundary, this interface between the air and the glass. When I put broken lines here, this is the path, the actual path this ray is supposed to travel. If the rectangular, triangular glass prism was not here, you extend this line. Good. Then you take it away. Now, this is supposed to be our ray, our incident ray, which is optical pin 1. Label it your pin 1. Then I told you in the other video that the distance between pin 1 and pin 2 should be 4 cm. And I'm going to do exactly that here. So this is 4 cm. So you place pin 2 here. Don't make too much holes. This is pin 2. The pins must be erect, meaning they must be standing upright. They must not bend. These are part of the precautions. The next thing to do is to replace this guy back to this place. Here. And then we have to view this guy at surface AC. If you view this guy at surface AC, you observe something. You observe that here, you view this guy at this surface, and then you will see that this pin and this pin will appear down here. And then you have to put pin 1, pin 3, and pin 4 in line with the pins you see in the glass. That is just what I'm supposed to do right now. Good. So you are free to turn. This is surface AC. The pin is inserted as surface AB. Then how to view it as surface AC. So I can rotate this and bend. I can see the pins from here. So this is Pin 3 is in line with what I see in the glass. And then the next pin. Good. I'm done with the job. So this is what the diagram is like. Good. The next thing to do is to quickly level this, remove this glass, level this as your pin 3, as your pin 4. And then join these two lines. The straight line must pass through it like this, not at the edge. So you join it like this. Good. And then on reaching this boundary, you have to put broken lines straight. Good. So this is supposed to be your incident ray. You put an arrow, the incident ray, and then there's a point here. You have to draw a normal perpendicular to this surface. You may use your protractor to draw this normal quickly. So that will be perfect. Good. This is your normal. So just draw something short, not too long. Good. So you have this normal and then you have this one. The next thing is to join this point and this point, which is supposed to be your refracted ray. Good. And this is your refracted ray. So the incident ray, the refracted ray, and then the emergent ray. This is how it looks like. Good. Now, this angle is the same with this angle. And this angle is called the angle of minimum deviation, dm. That is the angle we are looking for. We are looking for dm. We are looking for dm. D subscript m is what we are looking for. So this time we bring out our protractor. Don't forget this is your incident angle. Your I is 40 degrees. And this is your R1 and this is your R2. Refracted angle 1, refracted angle 2, and this is the refracted ray. So we are looking for this angle. Then you place your protractor in such a way that this point will be at angle 90 and this dotted line with this line will align with this. So we place it this way. Good. We are concerned with this and this. So let's count. This is 10, 20, 30, 35, 36, 37. So our D is 37 degrees. At this point, we are going to use these two information. Don't forget I told you our A is 60 degrees. So from this equation, we now plug in these values. This is the same thing as sine 1 over 2 into 60 plus 37 all over sine 1 all over 2, 60. If you do that correctly, we have we have 97 we have a n g is equals to sine half times 97 divided by 60 by 2 will give you 30 divided by sine 30. If you compute, you have 97 by 2, so this implies you have sine 48.5 divided by sine 30. If you do that, you have sine 48.5 will give you 0.7490. 0.748990 divided by 0.5, and that's 0.5, 0.5. If you do that correctly, we have 0.7490 divided by 0.5. Whoa, what an accurate result. We have 1.498. So we have a and g is equals to sine 1 over 2 into a plus dm divided by sine 1 over 2a, and that gave us 1.498. So the refractive index of this guy approximately to 1 dp is 1 point, we'll round it up, 1.5 precisely. Don't forget to subscribe and share this video to those that need it. Share this video and make others to know about physics with them. Click in the description box below and watch the theory on all refraction of light through triangular glass prism, rectangular glass block, and all the calculations therein. Thank you. God bless you. Bye-bye.